Hey guys, ever have that problem where trying to add something to an array tells you need to change from a let to a var on the array, and you don't know why, but you just do it anyways? Well, that's called a mutating function. Let's talk about it. Hello everyone, welcome to the dev method. Today we're going to talk about mutating functions and why they're important. How do you use them? How can you make some yourself? So the example I just gave was about an array, and then you want to be able to add things to the array, and then it tells you that you have to change something about your code in order to actually call that method. So let's just take a look at that real quick. Let's just do an example. I'm going to make an array of numbers. Here we go. Big numbers, smaller numbers. Okay, so now I want to add, let's say 10 again. So you do append, right? 10, like so. Run it through. Whoop, spelled numbers wrong. There we go. So 10, run it, and then it tells you cannot use mutating member or immutable value. So what does that actually mean? That means that this method that is on the instance of this array is trying to mutate its core data structure, its underlying value. So the problem here is that we don't necessarily, at least right now, we do not have any other way to add things to this array except by when we first created it. So just to give you an idea of what this actually looks like, let's just say, call this my array, okay? And then we want to use this function called append, okay? And let's just say right now what it does is that it changes a count, okay? So if I wanted to append something to the array, it mutates the array itself, the actual instance. So let's say when I append to the my array, I wanted to actually mutate the count. So what could we do? We could say count plus equals 1. So adds 1 to the count and then assigns it back to count. So notice it says the left side of the mutating operator isn't mutable, and then it says self is immutable. Well, to fix that, you do mutating. So if you were to look up the implementation of array in Swift, you'd actually see this. It would say mutating func and then append, so that you can append things to the array. So that's the idea. Now, let's say we create our array again, so I'll call it numbers, okay, my array. And we're not gonna add numbers to the array, but the whole point is to get to this part where we do numbers.append, okay? Now watch what it says. Yep, same error that we had before, cannot use mutating member on immutable value. And it says that it's a constant let. So if I were to change this to a var, now numbers.append can actually work. So just to prove that that is actually working the way you think it would, let's just say numbers.count and then print numbers.count. Here we go. Play it back. We should see two different things. Yes, I see here 0, and then I see 1. Let's actually make this a little bit cleaner for us so you don't see all that weird stuff with the new line character. There we go. We can also see the output here at the bottom too in the correct order, but this shows it by line. So the first time it's 0, and then the second time it is 1, right? So if we did let, we couldn't even actually call this method. This wouldn't even work. So here's the thing. The idea here is that let is defining a constant, and anything that is declared of that instance that could mutate what it is, therefore it's not constant anymore. It is changing some of its internals. So the whole point of this is that's why I'm bringing this up, is that Swift actually helps you when it's a struct like that. So let's take a look at another example where it's actually a class. So let's just say this is a class. So classes actually don't have this type of issue. There is no mutating. Now, it's not necessarily an issue of classes itself and Swift's version of classes, but they don't have that extra safety, that compiler check for your code. So in this case, notice mutating is gone, and then I have this append, and now it's updating the count here. So in that case, the count here has been mutated, but there's really no way to know because see, number is actually a let. So numbers is a let, and then we get the count, it's 0, and then we modify it, and then now it's 1 again. So another way we could do this, let's just change this not to an array anymore. Let's just call it counter. And I'll call it counter, and I'll get it on all of these. Here we go. And instead of append, I'll just say increment, right? So we have a counter, and then this could, see here, it's telling us, has nothing called append. Let's see. All right, so this is telling us that we can have a counter. By looking at this code, even without the compiler running, I have a class, and I have a constant class counter, or a constant instance of it, and I can get the count from it. I can also call increment on it, and then I expect the count to change. That's because I see the implementation right here. Now, if I change this back to a struct, now it's going to yell at me again and tell us this needs to say mutating. Here we go. Now we're okay, but now it says you actually need to declare that in your code. So var counter increment. So it's another tool when you're creating your classes or structs to help you and then help the people actually using your code, the other developers, to understand what you can and cannot do and when something is actually mutating the underlying structure. So there's a big reason why you'd want this. It's not just for this one reason of having the compiler help you understand that you're mutating the internal structure or the internals state of your instance. But there's a big part here with just vars and lets in general. So let me actually get rid of this here just for a second. Let's go a little bit further down. I'm going to declare my own number, and I'm going to say that number is 99. Okay, it is a var. So now later on, maybe 100 lines later, I want number to be something different, like 10. Okay, so that's possible. If I was to run this, that will work. The compiler will not complain about that. So we're taking number and then assigning it to this value, which is 99. And at this point, it's actually an integer. So now I can assign number to be any other integer value itself. So it's no longer about properties, but it's just about the actual instance that you declared here. So when we did 9, it declared it as, well, I wrote it as number. It's an instance of int, which is short for integer, and then we assign 10 to it. Now, if I take this and say let, notice we cannot do our assignment from being 99 and now changing it to 10. So it's actually telling us cannot assign to this value because it's a constant. So there's a big point in here about constants. So let's just say, for example, if you're doing some iOS, this will be very familiar to you. Let's just say you had a view controller, okay? I'm not gonna go on with what an actual view controller is here in this episode, but this is the idea. You have something that wants to like coordinate the information from one place to another and then maybe make some modifications and operate on it. So if I was to declare a let as a property, and let's just give it counter here. Okay, counter, so it is a type let. Notice here, that's fine. We just need to make an initializer so we know what counter is going to be. I'm gonna skip that part and just give it an instance of counter right away. So now if I declare or create an instance of this view controller, that view controller has a counter. If I do vc.counter.increment, Watch what happens here. We'll actually be told that counter is a let. Now I actually can't change that because I didn't implement that class. You would think, oh, I could just go like this and now it'll work. Well, yeah, it'll work. But now you have this other option or this other issue that you might have. So let's just say vc.counter.count and vc.counter.count. Let's just see what those two values are right away. So first it's going to be 0 and then 1. Now an issue you have here is you have the counters now assignable by someone from the outside. So you can say counter equals counter again. And then what is the vc.counter? Well, let's see. Oh, dot count. There we go. Should probably just call that value. Print, maybe. There it is. All right. So I finally got the stuff on the right-hand side to help us here, and it's telling us that it's 0. So yeah, not the best way to then maybe structure your properties by making those vars. So you have to be careful with how you do this. Now, there's a couple workarounds. You could say that this is a private set var, which means that you will not be able to set this again. But notice, see it says increment is a mutating member on the value. So the setter is actually inaccessible. But if I was internal to view controller, I could then actually change what this is. I could call that increment, but only inside the implementation of view controller. So it's really up to you on how far you want to take it. But that's actually like a big issue that you might see when you're writing your Swift code is you might not understand why you have to change something from let to var. I just want to show you now here another example. So let's say that, let's scrap what we have here. We have a struct, okay, and it's animals or animal, okay, and each animal can speak, okay, and then it does something, okay. So let's just say animal here, you have other kinds of animals. So here's the thing, struct, let's just say a lion. And if you wanted to then subclass it, and then you're gonna override func speak, and then you're gonna say it's roar, okay, like that. We're actually gonna have a problem with this. So here it's saying inheritance is not available from animal, and speak is not something that you can override, right? So let's just change this to a class. Okay, so we got around that, right? But you won't be able to do that with other types that have already been defined, like the array that we talked about, or even like int. So this class here is now allowing us to override this, so that's great. That's fine. But now let's go back to the let constant. Let's do the counter again, and we'll have this time it just say be a value, and mutating, increment. Okay, right? So there's our counter. Now we're gonna have our animal have a counter, okay? And we're just gonna start it like so. There it is. Oh, forgot the func keyword. Okay, so this all works out. The compiler is okay with this. So we have animal, which is actually now a class. And so we have lion inheriting from animal. That way we know that we have a speak on lion. So here's something that we have to take a look at though. A counter here, right? Now every time I speak, I'm going to increment, right? Okay, can't necessarily do that. And if, just to add on to it, We'd have to actually have like super speak so that we know that that's always supposed to happen. So we actually can't do that. And then also too, like what if the counter, we want it to be something completely different? Like maybe lion has some sort of something where you could pass in a counter. So the counter maybe is already incremented a couple times and then you're passing it in with those particular values. You do self counter equals counter, right? So this is one of the problems that you might have when dealing with classes, and then you want to, or maybe you're forced to by the framework to use subclassing, but now you have these different things when it comes to the mutating functions that was declared on some of those model objects like the counter. So first of all, we actually can't even call this. So you might think, oh, we'll just change this to var. So that's great. Now you can see here, oh, I gotta do super.init. Okay, so there's already an initializer, even though there's not one declared for animal, there's already one there. So now I can initialize it with a counter, but then again, I've now leaked my animal to have the counter be a var, which then anybody could increment. So not the best way to do that. So you want to plan these things accordingly, and you want this mutating func to really help you understand like what you're actually changing. One thing that you could do too, like let's say value couldn't be read from, so that's probably a good thing, right? So now the only way that value could change is through increment. We could also have one for decrement as well. And then you could have a func here, like an accessor that says get the value. Okay, and then you just return self.value, like so. Let's see, we'll change it to get value. There it is. So self.value. Now, if we wanted to, every time we roar, show what that does, so we would just do self.counter dot get value. Oh, and get value has to return an integer. There we go. Okay, so we got this far, right? So let's make my animal, which is a lion, and it needs a counter. There we go. Implemented the counter. So now animal.speak, animal.speak, and now animal.counter.getValue. So what is that going to be? So it's 2. So speak happened twice. But now what if I did, right before I called that animal.counter equals counter, because that's totally allowed by this API that's been defined. It's a var, so I can replace it with something new. What is that going to equal in the end? Well, now we're back to the original problem that we had before, so that it's 0. So if we build some accessors to some of these things, but maybe hide some of the implementation, we only get the value here, so that's pretty cool. Let's just say now we want to make this more like Swifty, more ergonomic. You probably would want this to be a val, and then this a var. Okay, but then it returns an integer, right? So sometimes this is used, you use underscores as like the underlying storage type, but then you have something that looks a little bit easier to understand with the actual, yeah, there we go. It's the actual name of it here. So it's hidden like that. So that works. Notice now, let me change this. So the last thing we want to do is change this, and we want this to be a constant. Okay. Now what we're going to run into a problem here. Yeah, can't call increment on the constant, right? Yeah. So var, let's try that private set here. Okay. Now we can do the increment, right? Now we won't be able to replace counter. That's just something that we can't even run. Can't do that. And then now we have another problem here though. So you see how it says const is, it's inaccessible. That's because it's a private here. So the only other way to do this is to make it like file private. So that's a way. But then that would require you to write class lion inside the same implementation file as animal, and that's not always possible. So you won't be able to do that. Yeah. So that's a little bit about the mutating function and where you might run into it for iOS. If you guys have any questions, you can leave them in the comments below, and I'll do my best to answer them. If you guys want to see more real-life examples of mutating functions, just let me know. But hopefully this helps you. Have a good day.